All right, so today we're going to talk about how to graph quadratic inequalities with two variables by hand. So one thing that's really important to notice is that these are not the same as the one variable quadratic inequalities that we solved back in activity 7. So notice that this has a y. The previous inequalities that we dealt with only had x's and then constants, coefficients, and whatnot. Here we have two variables. So these ones are ones where we're actually going to end up shading part of the coordinate plane. So just making sure you notice the difference between those two. If you need to go back to review the one variables, those are in, I believe, 7.4. But I've got the steps all written out for you here. The first thing that we're going to do is find and plot the x-intercepts of the quadratic by setting the function equal to 0. Notice it says equal. We know it's an inequality right now, but we're going to substitute an equal sign and we're going to solve. So notice how once again factoring does not go away because that's generally what we're going to attempt to do in order to solve. So I'm plugging 0 in for my y and I'm substituting an equal sign temporarily. Now I'm going to factor this. Remember that when we factor and your x squared term is negative, you want to factor out that negative because factoring is much easier when we are dealing with a positive squared term. So you can always check it by making sure if you distributed the negative, it's going to give you back this, which in this case it does. So now I'm going to factor x squared plus x minus 6. So numbers that multiply to negative 6 add to positive 1. So that would be positive 3 and negative 2. So that means that I'm going to end up with x equals negative 3 and x equals 2 for my zeros, which means that I have x-intercepts, because it says to find and plot, so that means you want to list them. Remember that when we list intercepts, they should be ordered pairs. These are solutions, roots, or zeros. It's not exactly the same thing, so make sure that you list them in the right format, which in this case is in ordered pair format. So I've got my x-intercepts. Next, I am going to find and plot the y-intercept. Now, the shortcut for y-intercept, yes, you can always find a y-intercept by plugging in 0 for x, but when we're dealing with quadratics, and it'll be the same for polynomials, the y-intercept is just going to be whatever your constant is. So in this case, my constant is 6, so 0, 6 is going to be my y-intercept. Finally, here I am going to find and plot the vertex. Now, you've learned two different ways to do this. You can either find the vertex by using opposite of b over 2a to find the x-coordinate, or by averaging the two x-intercepts to find the x-coordinate. It's not going to matter. You're going to get the same answer either way. So in this case, I'm going to average the x-intercept. So for my vertex, I know then that x is going to be negative 3 plus 2 divided by 2, which is negative 1 divided by 2, which is negative 1/2. So I get the y-coordinate by plugging in the x-coordinate. So y, here's my function, opposite out in front. Then I've got negative 1/2 is what I'm replacing for the x. Notice I'm using the parentheses. Those are important for keeping our signs accurate. So negative 1/2 squared is positive 1/4. But then I multiply times negative 1, so that gives me negative 1/4. Then I have minus negative 1/2, which is the same as plus 1/2. So that gives me positive 1/2, and then I'm going to add 6, which gives me, this gives me positive 1/4. So then I'm going to add 6, which gives me 6 1/4, which is the same as 25 over 4. So my vertex is at negative 1/2 25 over 4. So it's always a good idea to find your key features before you start plotting them, just because if you go ahead and plot the y-intercept and then realize, that your vertex is off the graph, you're going to have to erase everything and change the scale. So I always just wait to make sure everything's going to fit. Here, because my vertex is at 6 1/4, I know that this parabola opens down because it has a negative in front of the x squared. Remember that negatives make frowning faces because negative people frown. So that's how we know that. So I'm going to plot these points because it looks like they're all going to fit. So -3, 0 is right here. 2, 0 is right here. 0, 6, 3, 4, 5, 6 is right here. And the vertex is really close to it, -1/2, 6 1/4. So the vertex is just barely above that y-intercept. So I know I'm going to connect this with a downward facing parabola. And I totally just messed that up. I should be connecting it with a dashed. So this should be a dashed parabola. So I've got part of it that's going to look a little too connected. Sorry about that. I don't have an eraser on the equipment I use here. So imagine that the whole thing looks dashed. It does tell you on here, connect the points with a solid parabola if it has an equals with its symbol, dashed if it doesn't. So I'm glad I caught it before I screwed the whole thing up, but the whole thing should be dashed there. Now we need to know which way to shade. So we need to pick an ordered pair that's not on the boundary. So 0, 0 is the easiest thing to pick, which we would pick as long as it's not on the boundary. So if I pick 0, 0 and I plug it in, I get 0 is greater than -0, which is 0, minus 0, plus 6. So is 0 greater than 6 is the question we're asking ourselves. And hopefully we're saying no, 0 is not greater than 6, which means we should not shade where 0, 0 was. So we're not going to shade the inside, which means we're going to shade the outside. So outside of the parabola gets shaded. The solutions to the inequalities are all the ordered pairs in the shaded region. We do not include the boundary line this time because we have the plain exclusive greater than. Okay, let's do one more. So here, temporary substitution of the 0 here, and I don't have a GCF, so I'm going to go straight to seeing if I can factor another way. It's not a special product. So I'm seeing, are there numbers that multiply to -5 that add to +4? I'm going to say yes, there are. +5 and -1 satisfy those. So that means my solutions to the equation, not the inequality, but to the equation are, and sorry, my equal sign got really drug out there. Here, I'll drag out the other one to match it. So 1 and -5. And so that means that my x-intercepts are at -5, 0 and +1, 0. My y-intercept, remember, is going to be at the constant. So in this case, my constant is -5, so 0, -5. I know that this parabola is going to open up because my x squared coefficient, which is 1, is positive. So this will make a smiley face parabola. I now need to find the vertex, and again, totally up to you which method you use. Let's say, since I did the other method this time, I'm going to use opposite of b over 2a. So vertex x equals opposite of b would be -4 over 2 times 1, which is 2. So that means the x-coordinate of my vertex is -2. I'm going to plug that in to find my y. So -2 squared is 4. 4 times -2 is -8, and then -5. So 4 minus 8 is -4. minus 5 is negative 9. So let's see, I don't know if that's going to fit. 3, 6, 7, 8. So that doesn't quite fit on my graph. So that means I need to choose a different scale. I'm going to count by twos. So you can either write by twos on the y-axis, or you can actually label this guy a 2. That would be sufficient. I'm going to leave the x-axis counting by ones because they don't need to match each other. So I've got 1, 0 right here, and negative 1, 2, 3, 4, 5, 0 right here. My vertex now, I didn't list it as an ordered pair, shame on me, negative 2, negative 9. So negative 2 would be right here, and then 2, 4, 6, 8, negative 9 would be right here. This time I'm going to check first. My symbol has the equals, so when I connect these, I want to do so with a solid boundary this time. Sorry, it's not looking very parabolic there. Now I pick my point. 0, 0 looks good. I can pick it again since it's not on the boundary. So plug that in, 0 greater than or equal to 0 plus 0 minus 5. So we're asking ourselves, is 0 greater than or equal to negative 5? Which, yes, it is. So that means I should shade the place where 0, 0 was. So in this case, my shading is going to go inside the parabola. So sometimes you're going to have shading outside, sometimes shading's inside, sometimes parabolas open up, sometimes they open down. But either way, we're going to do all of these same steps every time you go to solve it by hand.